Welcome once again to another editions of mathematics here. Um, Now, today our task is to try to fix this error on my left hand side. Right now, I have been working on sorry, excuse me. I've been working on integration by substitutions um, on this topic. Okay, and then there are three different choices of substitutions that we can use here. Okay, right. So just look at the topics below. We are on integrations by substitutions. We're going to spot the error on the left hand side. There are three types of choices for substitutions. Now, let's take a look at the first choice below here. Substitution using u equal to 1 plus square root of x minus 1. Mainly for solving this integration. Alright. Now, I have worked out this working here with my students, and then we found that the answer does not tally with what the calculator was showing. So here today we're going to try to spot the error. Okay, I think that some of the students has already spotted the error, but here I just want to clarify where the error is actually found. Okay, so the main error is actually found over here. Okay, right. Now, before we look into why there's an error here, I'm going to walk through the first substitutions methods using u equal to 1 plus x minus 1 square root. So you can check out the title one more time down there. The choice we're going to make is substitutions using u equal to 1 plus square root of x minus 1. Alright, let's get started. So using substitution, I'm going to rewrite that formally. Substitution of u equal to I think it's u equal to x. Hold on, just let me clean that up. All right, u equal to x minus 1, is it? Or is it okay, so I'm going to start off by, alright, I think I made a mistake here. It's supposed to be u equal to, yeah, hold on. So the substitution is u equal to 1 plus square root of x minus 1. Alright, so I'm going to use this. Okay. So by working through the general setup, we have du dx equal to 1 over x minus 1 here. Okay. And then we can rewrite this as 1 over 2 u minus 1 here. Right. For x, we're going to set up the lower boundary and upper boundary also. For x equal to 2, our u is equal to 2 also. For x equal to 5, our u will be a 3. Okay. Now once we have done with this setup, we can substitute all this into this integration. So let's take a look at how does it look like. Now, yeah, before that, I would like to give a credit to Rahul, who suggested this substitution. All right. So let's try to use this method here. So we have 1 over u, and then dx, in this case, dx, this is where the error is located. Now, just let me reiterate just let me specify the errors one more time here. So the dx, I should be writing my dx as my subject. So if I write it down correctly, it should be 2u minus 1 du instead of dx equal to 2 du over u minus 1. This is where the mistake is located. Right? I hope that is clear. Now let's use these substitutions now to finish off this integration. Right? So we have 1 over u. Dx is 2u minus 1 du. And then our lower boundary and upper boundary has been changed to 2 to 3 here. Alright, so from here we are quite ready to start up the integration. So in this case we have 1 minus 1 over u du. And then let's give it a try. In this case it will be u minus ln u. By substitute the u lower boundary and upper boundary for u, we would be able to reach this conclusion. So ln 3, just let me put a bracket there. So this one will be 2 minus ln 2. And then finally our answer would be a 1 plus ln 2 over 3. Okay, so that's how the correct answer be. So in this case, it is 2 multiplied with bracket 1 plus ln 2 over 3. Right, I hope that is clear. Methods number 1. So we have done with the first choice of substitution. So it works. This method is quite direct. It leads us to the integrations result quite easily. Okay, so I hope that is clear. Now next, let me clean it up first before we move on to the next one. Okay, so we are clear on this. Right, next method of substitution by using a different choice. This one was suggested by Si Heng. Alright, I'd like to thanks Si Heng and Rahul for this. So we're going to try to use this method u square. So the second method is u square equal to x minus 1, or you could write as u equal to square root of x minus 1. Alright, so you can check out the title for the substitutions below. Okay, let's get started with the second choice of substitution using substitutions method number 2. Substitution 2 in this case. So we have u equal to you can say that u square equal to x minus 1, right? And then you can apply implicit differentiation here. We will get 2u du dx, which is equal to 1 here. And then indirectly we can specify that dx is 2u du. Right. And then at the same time, we are going to change the lower boundary and upper boundary. For x equal to 2, our u would be a 1. For x equal to 5, our u will be a 2 here. Right? So once we have done this setup, we are ready to substitute here. Here we will have 1 over 1 plus u, because the square root of x minus 1 is actually a u. And then dx, dx is 2u du. The upper boundary and lower boundary is 1 to 2. Okay, so from here we can rewrite as u over 1 plus u du. Okay, now we know that this is an improper fraction. Therefore, we can write this in its partial fractions form. So I hope that I got this correctly. Just let me check for a while. It's supposed to be 1 minus 1 over 1 plus u. If you use long polynomial divisions, that would do the job. Okay, so that would be this. Let me check for a while if I got it right. Yes, okay. So this is the partial fractions for this improper fraction. Now, once we are ready, we can integrate this quite directly. So that will give us ln 1 plus u, and then let our lower boundary and upper boundary here. So from here, we will have a 2 minus ln 3, subtract off with a 1 minus ln 2. Okay. And then in this case, we have a 1 plus ln 2 over 3. And then again, we have reached the same conclusions here. So I hope that is clear for the second substitutions choice that one of you suggested, Siheng suggested, right? So well done on this. I hope this is helpful to your understanding. All right. Okay, next. I'm going to clean up first. Now, the last method suggested by one of my students, also Siheng, he said that it's quite interesting to work with. So I would like to give it a try though. I've never done this substitution choice before. Now, since it is suggested, yeah, why not give it a try to see whether it works or not, right? If it doesn't work, we learn something new. If it works, we also learn something new. So there's nothing to lose here. Now the third method of substitution is below. You can check out the title. We will let u equal to 1 over square root of x minus 1. Okay. Now let's get going. So we're using substitutions number 3. Substitution 3. Okay. We will let u equal to 1 over square root of this. Okay. And then we're going to perform the differentiation as usual. In this case, we will have negative half x minus 1 to the power of 3 over 2 here. But sometimes it's better to write, from my perspective, I prefer to write like this. Some of you may be able to see as to why I would be writing in such a way in a while. Okay. Now the main reason here is because of these substitutions that I have, or one of you has suggested, right? So I could have written this as du dx. I'll rewrite that again as negative 1 over, because 1 over square root of x minus 1 is u, so therefore there is actually u to the power of 3. And then for that, I can write my dx as my subject. That would actually give me a negative 2. Okay, I better do this correctly. So in this case, it's negative 2u cubed du. Right. I hope I got it right. Let me see. Yep. Okay. So that will be the setup that we need. And then the same thing, we're going to define its lower boundary and upper boundary. So for x equal to 2, our u is equal to 1. For x equal to 5, our u is equal to 1 over 2. All right. So now we are ready. We're going to substitute all this setup into here. So what we have here is, now we don't actually see how to actually put this one into there. But we do know that I'm going to make a remark here. Some of you may not be able to see that, but we can restructure this algebraically. That will be 1 over u. So we're going to make use of this structure for our substitution. So therefore, that will be 1 plus 1 over u. And then dx, we know that is a negative 2 over u3 du. And then the lower boundary is 1. Sorry, is it lower boundary? Yeah, correct. Lower boundary is 5, 1 over 2 here. Okay, just let me check properly in case I got it wrong. Is 5 is, yes, correct. All right. So from here we can rewrite that as, if you restructure it properly, we have negative 2 here. And then we have, let me see, what do we have here? We have a du, and then this one will be a u. Is it a u square? Yes, correct. It's a u square u plus 1. Okay, just let me check one time if I got it correct. U square u3. Yes, correct. Integrate that from 1 to half. Now, some of you may be a bit confused as to why the upper boundary and lower boundary has changed. Don't worry, that's because of the substitutions that we're using here. Okay, now for this, you can see that we can express this in terms of partial fraction, right? Now for me, I have already worked out the partial fraction just to save some time on going through the partial fraction here. So I'll just write down the format for the partial fraction. Just let me check if I recall it correctly. So the partial fraction is 1 over u plus 1 over u square, and then finally we have 1 over u plus 1 du. Integrate that from, okay, just let me clean this up properly. That is from a half to a 1, from 1 to a negative half, right? Okay, you can always check your partial fraction in case I made a mistake here. So therefore, in this case, we have this part will become a negative ln. This will be a ln, so I can actually combine both of these ln together. That would give me a ln u, and then this would give me a 1 over u instead. Okay. And then we are almost done here. All right. And then by substitute all this value in, you will be able to get, okay, just let me check here. This one will be ln, okay, let me see, 3, this is, oh yeah, this is ln 3, and then minus 2, okay, bracket that, and then minus of ln, that is 2, and then minus 1. And then let me check whether the answer is correct. So in this case, we have minus 1, and then minus 1 plus ln 3 over 2. 3 over 2. Or it could be 2, 1 plus ln 2 over 3. If I move the negative into the bracket. And then here again, we got the same answer as the 2 substitutions method. So therefore, we can conclude that the choices of substitutions are all feasible, and then we are able to reach the same conclusion. And then if you compute it using machine, you can also verify that the answer is exactly the same. All right, I hope that has been a useful journey to your integration technique. All right, So today we will end at these sections. If you like what you are looking at, do remember to subscribe, press the notification bell so that whenever there's a new video uploaded or published by me, you will be able to receive the notifications. All right. Until we see you again, happy learning and then enjoy your cheesecake. All right.